monthly license contract. Okay. And this is the last topic. Just quickly introduce the testing IP, popular configuration, and how to start CTS. So this is just I pick up the major application, so-called we call testing IP. So this is a basic OS and functional testing IP. And DC parametric measurement IC like this. So you can check in our website, and you can see the monthly, pricing. This is the last slide. How to get started CTS. Number one, actually we'd like you to register, CTS ID in our website, and then you can download the user's manual, fully covered, and also hardware specs, and also we are providing the test board, making test board guideline. And number three, we're gonna send the cloud testing station test the hardware and delivery request based on the request. And lastly, you need to select testing IP and also purchase accessory like the cables. Also, you need to prepare a testing board and PC. And lastly, you need to select testing IP and purchase monthly base. Yes. So this is just a very simple procedure for you. And for more detail, please come to our website to understand more detail. Basically, that's all about my presentation. And thank you very much for your time. And let's communicate with you later on. Yeah, thank you very much.
For tea, coffee break, and we'll reassemble at about 11. It's 11:05 on my watch. 11:20, 15 minutes. Yeah, thank you. Kind of listen to some deep dive technical sessions and case studies and applications by Takeji-san. He is the system engineering head for CTS, and let's look forward to an interesting session. Yeah.
Okay, hello everyone. So thank you for joining my presentation. So my name is Ryosuke Takeuchi. I'm System Engineering Manager of Cloud Testing Service. So on my presentation, I'll explain about CTS applications. So after this session, you will understand what type of devices can be tested by Cloud Testing Service and what types of measurements are available in CTS. So my presentation consists of those two parts. On first half, I will explain about various solutions of CTS. And on second half, I'll introduce some use cases of CTS. So let's begin from various solutions of CTS. So most devices are designed on EDA tools like Synopsys, Mentor, and Cadence. So we have developed the EDA link solutions. If your EDA tool output style file, our software called Style Reader can convert the style file into our CTS format. And also we have a product to convert VCD file and also WGL file. So we cover those most popular pattern formats. So you can easily convert pattern file from EDA system to CTS format. In addition, we have a product called Style Writer. This product outputs style file from CTS to EDA2. So now you can close the loop. It means you can design the product on EDA link, EDA2, and output the pattern to CTS, and debug the pattern in CTS, and output its debugged pattern to the EDA2. So this is our EDA link solution. And this is also EDA link solution for scan analysis. As I said on the previous slide, we have a product called Style Reader. This product converts vector from ATPG2 to CTS, and then after running scan test on CTS, we output failure log. And we have a product called log synthesis. This product converts failure log output from CTS to other product which analyzes the failure log. For example, the output failure log can be read in the ATPG diagnostic tool, or we, Advantest, have the scan FF map tool. This is a tool to display the Weyham map of scan failure. So you can effectively analyze scan result with CTS and its related products. And this is the solution for I2C interface device. Some devices have I2C interface, and our product, Cloud Testing Station, has also I2C interface. So, and we have a software, we have a graphical user interface to control I2C interface. So you can very easily to operate the device via I2C interface. So by using this solution, no test vector is required, just special register address and data. And we can read register value and compare it with expected value. And voltage, current, frequency, and power supply current measurement are available. And also debug features such as suspend, trace execution, and so on are available on this solution. So if your device has I2C interface, this solution will be very effective to debug your device. Next solution is external instrument link for GPIB. So our cloud testing measurement tester is equipped with digital I/O pins, device power supplies, parametric measurement units, arbitrary waveform generator, and digitizer. So most devices can be tested by our single tester, but in some cases, our hardware equipment is not sufficient. For example, if your device has, if your device requires more than 10 device power supplies, our device supplies will not be enough. So we developed such kind of solution. So by using this solution, cloud testing station and external instruments can be operated as one unified test system. You do not need to program the external instruments. So such external instruments can be programmed, can be controlled by CTS. So it is very, very easy to operate instruments, external instruments and CTS. So by using this solution, not only functional tests but also high accurate parametric measurements are also available with single test system. And this is a similar but slightly different solution for external instrument link. On previous slide, I introduced GPIB instrument link. But in addition, we have a solution to link with National Instruments PXI modules. So most sensors and analog ICs requires digital verification capability and analog verification capability. Both capabilities are required. On digital part, CTS has very powerful capability to control digital part and verify digital part. But if you need very high accurate analog verification, this kind of external module like National Instruments PXI 5124 is suitable for such analog verification. So in this solution, we cloud testing service generates the I/O signals and power to the device, and also we generate the trigger to the analyzer module. Then analyzer module captures the waveform based on the trigger from our system. So by this solution, we can very, very easily to mix signal device, which requires very high accurate analog verification. And this is another solution for test automation. So if we want to test wafer, we have a prober driver. By using this prober GPIB tool, you can control prober like Tokyo Seimitsu or Tokyo Electron. We have prober. And also handler driver is available. So in some cases, you want to do the small production for engineering samples. We have this, by using this handler GPIB tool, you can very easily to screen small screen engineering samples. And also we have a thermal streamer control tool. In the evaluation stage, in the evaluation phase, most devices require temperature characteristics measurement. So we have thermal streamer control tool. So by using this tool, you can very easily to capture the thermal characteristics of your device. And this is a sensor measurement solution. So in general, analog ICs and sensors requires trimming. To trim the device, normally following sequences are required. First, learn pattern and capture the digital and analog waveform from the device. And calculate the captured waveform and digital pattern, and calculate its characteristics of the device. And modify the pattern and run the pattern to trim the device. This is a typical sequence of device trimming. So CTS have all of those capabilities. So you can easily test and evaluate the sensor devices, and also manufacture the sensor devices by this solution. And in addition, we CTS have two types of configuration. First configuration is MCU type configuration. This is suitable for MCU, ASIC, and sensor devices. And another configuration is memory device test configuration. On this configuration, you can test memory devices like DRAM, flash, and SDRAM, and so on. So on memory device configuration, you can run function test at maximum 533 megabps. And to evaluate the memory devices, paired bitmap tool and shim tool is necessary, and we also have such capability. And as the earlier presentation, so Advantest has a very big share on memory test market. So memory device manufacturers have the pattern file for Advantest compatible. It means, our CTS pattern file for memory configuration is compatible with Advantest memory tester. So you can easily run the memory test pattern on CTS. Okay, so this is the solution, brief solution introduction of CTS. So let's move to the use cases. So on use cases, I did not put the actual customer name on my slides, but those use cases are actual and real use cases used by the customers around the world. So first use case is semiconductor device developer and designer. This customer used many measurement instruments such as oscilloscope, power supply, signal generator, and digital multimeters. But those capabilities are included in CTS. So this customer decided to replace those instruments with CTS. So by replacing multiple instruments, they achieved to reduce turnaround time for functional verification. And they also reduced floor space and power consumption. Because CTS is a single test unit and its power efficiency is very good, so they can reduce power consumption also. Next one is a use case at quality assurance team of semiconductor manufacturer. So normally, if the device failure found on the market, that fault device will be sent back to the manufacturer for analysis. To analyze the device, this emission microscope is widely used. To capture the emission from the device, engineer have to run the device to put it into the operating mode. And CTS can very easily to run the device. So this customer used CTS with emission microscope to analyze the fault device. So this is a case of returned material analysis called RMA. So this is a typical use case of CTS. And this is another use case for quality assurance. Cosmic rays, such as neutrons, sometimes cause the failure of the device operation. So, recently, many semiconductors are used in cars and social infrastructures. So misoperation of semiconductor devices is very serious. So this kind of evaluation called SER, software related testing, is very, very important. But without CTS, it is very, very difficult to do such evaluation, because to do this kind of evaluation, a customer have to bring measurement instruments to the facility which produces neutrons. But it is very difficult to bring many instruments or big tester. But with CTS, you can bring only one single tester, single CTS, to operate the device. And then customer can run the device with CTS and expose the device into the neutron beam, and then evaluate the operation of the device. So this is the case of the software-related testing. So CTS terminal is very small, so they can carry to the SER facility. And CTS is very easy to operate. So sometimes the QA engineers are not specialists for semiconductor tester. So it is not so easy to operate the traditional ATE automated test equipment. But CTS is very, very easy to operate. So QA engineers can operate CTS and set up it at the facility, so they can do it evaluation by themselves. So make impossible quality verification in special environment possible with CTS. And this is a use case in university. Not only semiconductor company, but also university or research institute are using CTS. So this is a use case to evaluate the next generation solar cell. This professor used many measurement instruments to evaluate this next generation solar cell. but he decided to replace those instruments with CTS. Because at universities, the operator of the tester is a student, not a tester specialist. So easy to operate is very important for university. So this professor decided to use CTS to evaluate this device. And in addition, the professor mentioned that CTS has a good repeatability. The reason why is to use multiple instruments, you have to wire up many instruments. So the contact of the connector will be slightly different for each time. So repeatability of the measured data is not so stable. But with CTS, it is very, very stable. So this is very good for research, he said. Okay, and this is another interesting use case at the semiconductor distributor. For example, very old facility like electric power plant requires very old devices because it is very, very difficult to replace, to redesign the circuit. So old facilities requires old end-of-life products to repair the facility. So this distributor purchased the end-of-life products from the secondary market around the world, and then they sell the procured device to its end user, like power company. But sometimes the procured device did not work, and they tried to analyze the reason of that, and they found that it was a copied product. It's a forgery. For example, the appearance says Samsung, but removing the package, its circuit was made by Hynix, and so on. So they found such a forgery case. So this distributor decided to screen the procured device by themselves. So it is a cost for the distributor, but they can sell the product with higher price. So they decided to do this screening by themselves. So without CTS, screening the device is very difficult. So it requires a large floor space and dedicated cooling system and so on. But CTS is very small and easy to operate, so such a distributor can use CTS. And this is the last use case. So Advantest has a long history of semiconductor tester. And some customers are using very old semiconductor test system, like 15 years old. So comparing to such old systems, CTS has much high accurate DC specification and almost same pin count. So it is possible to replace all test systems with CTS. So for example, the T3347 is the oldest test system, and it consumes 17 kilowatt. But this system can be replaced with 2 CX boxes for the string system, and it consumes only 1.5 kilowatt. So electric power consumption is almost 1/10. So the customer said, we can use CTS only for the electric power cost of the old system. Okay, in summary, cloud testing service are memory, MCU, ASIC, and sensor test applications are available. And GPIB and PXI instruments can be integrated, and they can be operated as a single unified system. And we already have many use cases on, such as design verification, silicon debug, quality assurance, failure analysis, small production, engineering sample sorting, and R&D at university and research institutes. So I believe CTS can help make your business successful. Thank you for listening to my presentation. Thank you.